Hello, AP Calculus students, and welcome back to our Topic 4 Applications of Derivatives lessons. Today's focus is sketching accurate graphs from derivative properties, which sounds pretty intense, but the long story, or maybe short story, hopefully, is that now that we know what f prime and f double prime do or tell us about f of x, we're going to use f prime and f double prime to sketch a more accurate f of x equation. And this lesson is going to culminate in a pretty intense question that is going to use all of your skills from the entire year, and it is going to be very exciting. So let's begin. Your job is to sketch a continuous function that satisfies all the stated conditions. And you are also asked to create the mythical triple sign chart, which is something we probably haven't done yet. So let's start with that. I'm going to go ahead and do my graph of f of x in green. I'll do properties of f prime in red and properties of f double prime in purple. So we're going to go ahead and just use this box for its nice straight lines here. And we don't have any endpoints, but maybe we'll just go -5 to 5 since that's what's on our x-axis over here. And we're going to have to split this into 3 parts. 1 and 2. Good enough. I didn't like that line. Oh well. And then we're going to go ahead and label each of these with f of x, f prime, and of course f double prime. Now, we actually need some properties for each of these as well. So they tell us that f has the property that f prime, and f double prime are all negative for all real values, which to me means that f prime is negative everywhere, f double prime is negative everywhere, and f is also negative everywhere. Now, there's a couple things that we're going to do to increase the accuracy of our graph. And I'm actually going to start with f prime and f double prime because we've played around with those more often than f, and then we'll go back to f. So if f prime is negative, what does that tell us about f, about our green equation? Well, it tells us that f is decreasing, right? When f prime is negative, f is decreasing. So I know then, and you might want to hold off on this because it's a little easier for me to erase and adjust than you guys, but we know then that my graph of f is going to decrease across my graph, across my coordinate plane. However, we need to give this graph some curviness, some flexiness, or some concavity, if you will. And since f double prime is negative, that tells us that f is also concave down. And notice that I'm trying to use green all the way through here to show you that these are telling you properties about our green function. So if our green function is a parabola, right, a parabola, and maybe showing you down here, has a positive sloped side and a negative sloped side, or an increasing and decreasing side. Because our graph is decreasing, I really just want kind of this right side of a parabola. So I'm going to go ahead and adjust this line so that it's more just a right side of a parabola. Would you agree then that this graph shows a decreasing function, that's f prime, and concave down, that's f double prime? But then there's one other piece they told us. They told us that f of x is negative. And you might have to remember back to your Algebra 2 and Algebra 1 days to understand what that's telling you. If f of x is negative, f of x are the y values. If the y values are negative, they're talking about the underside of the x-axis, or the negative side of the y-axis. So I usually just write below down here and pretend that this line is the x or y-axis. So if it had said a positive, I would have written above. That doesn't come up very often, but it's nice that you at least understand the connection here. And I'm writing above again because words are hard. Below. So I'm going to take this downward facing decreasing parabola, and I'm just going to make sure it stays underneath the x-axis. Throwing some arrows here, maybe you can consider x equals or y equals 0 an asymptote that we approach, and then we drop down from there. And there's our entire equation. So now that we get the general idea of this triple sign chart, why don't you guys go ahead and try our second one here. Same thing, triple sign chart. Though actually, let's argue, since they don't tell us anything about f here, let's just do a double sign chart. That's probably a better idea, I think, huh? So let's go ahead and do a double sign chart for this point. For f prime and f double prime, you should pause me, try it on your own, and then you can unpause and see how you did. Ready, set, go. All right, so I'm going to go ahead and sketch mine in really quickly, just trying to use the naturally given borders to help my somewhat straight lines here. And I'll continue those colors. So we have F prime, we have F double prime. Okay, and then what do we know about these? Well, I'll continue with F prime in red. We know that F prime of x is less than 0 if x is less than 1. So I think 1 is pretty important. I actually see 1 a bunch here. So I don't actually know what happens at 1, but I do know that F prime is greater than 0 for x is less than 1. Maybe again I'm going from -5 to 5 here. And we also know that F prime is less than 0. Oops. Greater than 0 if x is less than 1. Less than 0 if x is greater than 1. There we go. So what does that tell us about our function? Well, it tells us that f, again in green, is going to increase and then decrease. So I know a few things already. In fact, they told us that f of 1 is 4, 1 comma 4. So I know that I have to increase and then decrease. But I don't know about the curviness yet, so let's go ahead and take a look at this second part down below. They tell us for every x that isn't 1, f double prime needs to be greater than 0. So we are concave up and concave up. So that can be a little bit tricky, and I'm going to go ahead and split this into two sides, right? Where this left side over here needs to be concave up, but it also needs to be increasing. Which side of the parabola is increasing? Well, that is the right side. So that tells me that this needs to look like the right side of the parabola, and you can kind of see that curve going in, yeah? And then this other one needs to be decreasing based on f prime. And which part of a parabola is decreasing? Well, that is the left side. So I'm going to go through and slide this over a bit, and we're going to show that it's decreasing. And I think probably the only way that these two come together is this sharp point then. And that was silly of me. I should have kept it in green. Apologies. There we go. Something like this. Okay. We keep it in green. And then I think the only way these two parts of parabolas come together is at this sharp point or this cusp, which actually lets us fill in a little bit more information. It tells us that f prime does not exist, right? Sharp points don't have a slope, no f prime. And if f prime doesn't exist, then the derivative of f prime, f double prime, also doesn't exist. Should have done purple. And there we go. Alrighty. From here, we're going to make a kind of a quick reference table for today, just really more for some vocabulary. In the next class, we're going to really tighten this down and have a nice little graphic organizer about how everything relates. But for today, let's go ahead and talk about some vocabulary phrases that we should and shouldn't use with f, f prime, and f double prime. So here we go. We'll start with f of x, the OG, the original graph or equation. So we know that if f of x is positive or negative, then that tells us the graph is either above, and we'll work in green here, is going to be above the x-axis or below the x-axis. If f of x is increasing or decreasing, then what does that tell us about f prime? Well, because f prime describes increasing or decreasing, that tells me if f is increasing, it tells me that f prime is positive. So I'm going to say f prime of x is greater than 0. And conversely, f prime of x is less than 0. A lot of times I'll see students look at this and go, oh, f prime is increasing. But that's not what this positive here means. This means f prime is positive, and it means f is increasing. And confusing those two will actually lose you points on a free response. In a similar vein, if f of x is concave up or concave down, then we know that f double prime is positive or negative. And last but not least, we just discussed it. It says if f of x is a sharp point, that should probably say has a sharp point, which we sometimes call a cusp. Then we know that f prime of x does not exist. All right, well, now let's go ahead and talk about f prime. Right? If we know things about f prime, we actually know things about other functions too. For example, if f prime is positive, what do we know? Well, that's back up here. If f prime is positive, then my green function, f of x, is increasing. If it's negative, I should say it. If f prime is negative, then f of x is decreasing. But then this one gets a little hairy. If f prime is increasing, Do you guys remember what that is? Remember, increasing measures the slope of f prime. So they're saying the slope of f prime is positive, and the slope of f prime is f double prime. So that means that f double prime is positive if f prime is increasing. If these slopes are getting bigger, then the second derivative is positive, and vice versa here. If f prime is undefined, what does that mean about f of x? Well, that one's actually a little bit tricky because there's a few ways that that can show up, right? If f prime is undefined, it means that f of x, we're going to say, has an undefined slope. And that can occur in several ways, right? That could be a cusp like we saw up above. It could also be just a jump discontinuity, right? There's no slope there as well. There's a few different ways it shows up, but there's something weird going on with the graph of f of x. And last but not least, if f prime of x has a sharp point, we also discussed this up above, then we know that f double prime does not exist. Last but not least, let's talk about the second derivative. We know that if f double prime is positive, then f of x is concave up. Right? F double prime being positive means f is concave up, and the opposite is true. F of x is concave down. But this one's real tricky. Can you think about it? If f double prime of x is positive, then what does that mean about f prime of x? Well, it's really kind of working backwards from what we did over here, right? It tells us that f prime of x is increasing and negative is decreasing. And it's really tough to play around with this vocabulary accurately, to work back and forth, and I think that's actually going to be a big struggle for us for the next couple classes, understanding, wait, this is increasing, what does that mean about f? What does that mean about f double prime? But we'll narrow it down, and we'll give you some hints as you work through. Okay, so that's really the first part of our class today, just trying to understand the relationship between f prime, and f double prime. The second of 3 parts asks you 6 questions. In particular, they're going to give you facts about f prime, or the first derivative, and f double prime, the second derivative, and say, what does that tell you about f of x? Or, in the first question, g of x. And these questions are tricky. They're definitely worth spending some time on though, because there's almost always one multiple choice question every year that asks you something like these 6. So what you might want to do is actually try these 6 and see if you can find some success. And then you can come back to me and I'll try to explain it in a few different ways. So take a few minutes, try the 6 questions, and then you can skim through. If you're getting the answers right, you probably don't need to listen to me drone on. But if you're getting stuck anywhere, then yeah, you should definitely come back and see my explanation or hear it. Ready, set, go. Alrighty. Let's go ahead and take a look. Let g be a twice differentiable function. What does twice differentiable mean? Do you guys remember? Oh yeah, differentiable means that the derivative, you are able to take the derivative and the derivative exists everywhere twice for g. So not only does f prime exist everywhere, but f double prime also exists everywhere, or g prime in this case. Okay, and then we know a few things. We know that g prime of x, I should keep my colors here the whole time, I think. G prime of x is greater than 0, which means what? Well, that tells us that g is increasing. So if you want an increasing graph for g, and I should have switched colors, we'll get there one day. G is increasing. That means our graph needs to look like this, right? Increasing. And then they also tell us that g double prime of x is greater than 0. And this tells us 2 things. The first thing it tells us is that g prime is increasing. See the chart on the previous page. And it tells us that g is concave up. So we're going to come back to those in just a bit, but imagine you had a parabola here. It wouldn't be the full parabola, I don't think, right? Because they say that, well, g prime is increasing. Yeah, we'll go with this for now. That's fine. So we know that not only is g increasing, we also know that it is a concave up parabola shaped thing. Let's go ahead and read the rest of the problem. We know that g of 4 is 12 and g of 5 is 18. What's a possible value for g of 6? So I'm going to make a quick input-output table. X, g of x, and we have 1, 2, 3 values here. We have 4, 5, and 6, and g of x we'll do in green again. Great. We know the first output is 12, and the next one is 18. Okay, how do we do this? I see a whole bunch of options down here. You guys have filled in tables before, so maybe our first analysis should be to look at the slope. And if I look at this slope, right, the x's go up by 1 every time, which is very nice. So as the x's go up by 1, the outputs go up by 6. And I did switch to red on purpose because we're looking at the slope, which is g prime's job here, right? We went up by 6. Okay, well, you might say, well, there's a pattern. Shouldn't we go up by 6 again? And there's a few things we need to know. We actually might just want to start eliminating answer choices, maybe to get to where we need. So let's just start at the beginning. Let's start at 15. So my question to you is, could the next term be 15? If it was, that would mean that we would have gone down by 3. I think we immediately know that's wrong because they told us that g prime is greater than 0, which means g is increasing, which means to get to the next x value, we need to have increased, or my slope needs to have been positive. This was not positive, so therefore we couldn't have done 15. Similar vein, 18 mean we would have gone up by 0. But we said this is greater than 0. The slope can never be 0. So 18 is also out. All right, let's look at 21. That's our third option, yeah? 21 goes up by 3. These are both positive slopes. They're both cases of g prime being greater than 0, so it definitely works with our first criteria. However, what about that g double prime thing? G double prime tells us two things. And I'm going to show you the actual graph first, but then I'll show you how I'd actually think about it. The graph, since we know we're increasing, we're only looking at the right side of a parabola. And the way a parabola works is it starts really shallow and then gets steeper and steeper and steeper. And it doesn't have to be a parabola. I'm just using that as a shape reference. So what that means is our parabola goes up by a little bit and then gets steeper and steeper and steeper. And if the parabola is getting steeper and steeper, that means that we need to be going up faster and faster. Now, realistically, that also is the same thing as saying g prime, the slope of g is increasing. The slope of g must be getting bigger. So if I had a slope of 6, is my next slope increasing? No, it's not. And if it's not increasing, then we cannot get to 21. In a similar vein, if this was 24, that would have gone up by 6. Did my slopes increase? No, they stayed the same. And they said that g prime is increasing, greater than 0. So that's out as well. We check our last one, which is 27. That could have gone up by 9. Is that allowed? Yes. It was a positive slope, and it's a slope that is greater than the previous slope. So 27 is the only one that is a possible value. Most of the rest of these questions are going to be very similar to that. So I think now that you've gotten one of them out of the way, try to apply that knowledge for the rest. And I'll go quicker through the rest of them, I promise. Okay, so pause me if you'd like, but I'm going to move on to problem 2. All right, here we go. F has a positive first derivative, so f prime is greater than 0, and a negative second derivative, f not g, f double prime is less than 0. So it tells us a few things, right? It tells us our slope is positive, so the slope of f is positive. And it also tells us that although you could certainly say that f is concave up, it tells us the slope of f is decreasing. So we are going up by positive values, but the positive values are shrinking. So probably the best analysis of this is to look at the slopes of every single one of these and see what's happening. And again, I'll work from left to right here just to get a good indication. So we go up by 2, then 3, then 4. This guy goes up by 4, then 3, then 2. This one goes down by 4, then 3, then 2. This one goes down by 2, then 3, then 4. Nothing more stressful than doing math on the fly on a video, but that's okay. And then this one goes down by 3 every time. Great. As we look at these, which ones can we immediately throw out? Well, hopefully you said C, D, and E, because we know f prime is greater than 0. Our slope is positive. This is not a positive slope. These are making our outputs get smaller, which means this is a decreasing set of functions. The last two, we do have positive slopes, so we've checked off the first one. However, f double prime being less than 0 means when they took the derivative of f prime, they got negatives. It means f prime is decreasing. So the question we should ask is which slopes are positive but getting smaller? And if you look at that, I think that has to be B, right? Went up by 4, then 3, then 2. We are still going up, but we are going up at a slower rate. All right, let's try 3. For which of the following graphs or values of x is f prime positive and increasing? Well, let's translate that. F prime being positive means that f is increasing. So I'm going to go ahead and highlight where this graph is increasing. Looks like here and then here. There we go. However, they also said f prime of x is increasing. So f prime of x is increasing, meaning the slope of f prime is positive. So that actually tells us that f double prime is positive. But visually, we see that on f, it tells us that f is concave up. So it looks like this guy, right? So the question is, where on this graph is it concave up? And I really should have done it this way. So let's say we do our increasing in red. Increases all the way up to here, sorry. Good. And then let's do our concave up in purple. I'm seeing concave up really just from like here on out, yeah? That's the only concave up part. Yeah, the other two are concave down. So the question is, where do they overlap? And I'm pretty confident that's going to be E, yeah? We are concave up and increasing. Sounds good. All right, moving on to 4. F of 0 equals negative 5. F prime is less than 3 for all x. Which one's not a possible value for f of 2? Ooh, this one's going to be tricky. So we have x, and then we have f of x. Great. My inputs are going to be 0, 1, and 2. Looking pretty good. We know f of 0 is negative 5. And they're asking us about f of 2. So I think we should probably play the same game and see which ones of these can we get or not get. However, we are restricted. We know that the slope that we go up by every time has to be 3 or smaller. Now, 3 or smaller could be 3, could be 2, could be 1, could be negative 10, could be negative 10,000, right? We don't know. But 3 is the absolute max that we can go up by. So let's go ahead and just see what happens if we go up by 3, right? The absolute max. The most I can increase by is 3 every time. So let's see, negative 5 plus 3 is negative 2. Negative 2 plus 3 is 1. I think 1 is the biggest value we could ever get. Do you agree with that? If 3 is the biggest slope? So then how could you get 2? Well, I don't think you could get 2 in this case. I think 2 is probably the one that is not a possible value. We saw that we can get 1 if we go up by 3 every time. I'll show you how we can get 0, right? We could get 0 if we go up by 3 and then we go up by 2. Because it doesn't say the slope has to be the same. The slope can be any number that's less than or equal to 3. And in the same vein, I could even get negative 10, right? We could go up by 3 and then I could go down by 8 because negative 8 is smaller than 3 and that would get me to negative 10. So I think all of those are possible except 2. Okay, oh, here's another one, our good old friend. If f prime is greater than 0, right, that means that f is increasing. And f double prime is less than 0, it does mean that f is concave down. But I'm going to phrase both of these in terms of slope. We have a positive slope, and we have less than 0, we have a decreasing slope. So again, we'll look at all the slopes. This one goes down by 1, then by 2. This one stays the same, probably not that one. Up 1, up 1, up 1, up 2, and up 2, up 1. All right, let's look for positive slopes first. Not a positive slope, not a positive slope. Great. We also know the slope needs to decrease. This slope stays the same, so C is out. This slope increases 1, then 2. It's got to be D, right? It goes up by 2, then up by 1. Last one. Which of the following is true about the graph? And they're asking us about f prime here. So let's go ahead and remind ourselves that f prime tells us about increasing and decreasing. And they're asking us about three values. So I'm going to input these just in different colors on here. We have f prime of -1, we have f prime of 0, and we have f prime of 1. And they want to know, how do we arrange these from least to greatest? So let's go ahead and write these out, and then we can arrange them. Let's start with f prime of -1. F prime measures the slope of f. Well, if you drew a tangent line, that looks like a slope of 0, approximately, right? And then we also have f prime of 0. If you drew a tangent line, that line has a positive slope. That's on a part of the graph of f where the graph is increasing. So I don't know what f prime of 0 equals, but I'm very confident it's positive because our graph is increasing. And then we also needed to find f prime of 1. And to find f prime of 1, well, here's another tangent line. That tangent line is going down. It is the decreasing part of our graph, so this is less than 0. Well, we have a number that's 0, one that's positive, and one that's negative. Can we rank those three? I would hope so. I see f prime of 1 as negative, so that is going to be less than f prime of -1, which was 0, and that in turn is going to be less than f prime of 0, which is greater than 0, right? Just three slopes there, where we had our negative slope, our slope of 0, and our positive slope. And as we write that out, let's see, f prime of 1, -1, 0. Well, it starts with -1, that starts with 0, -1, 1, -1, 0. Oh, it's got to be D. Great. All right, so hopefully that does an okay job of kind of connecting how f prime and f double prime work together with the graph of f. But for the end of today, we have one question left. Yeah, just one. But it's honestly kind of a biggie. So let's see how we can put everything together that we've done for most of this year, actually. Right? And they ask us to go through and find several things about a function. They want us to graph the function x cubed over 3 minus 400x. Whoa, buddy. Now, I don't know much about that graph, but I can find a lot about it. And they're going to ask us to find many things. They're going to ask us to find on f of x the zeros and asymptotes, on f prime the critical points and absolute extrema, and then f double prime any inflection points. Then eventually we'll need a triple sign chart. There's a lot to this. Now this is not a typical AP question. The AP exam would not ask you to sketch a graph like this, but I really like concluding with this question for this lesson because it does a great job of both reminding you of what we've done in the past and gives you a nice idea of how we can bring everything together. So let's begin. I'm not sure the best way to organize our work here. We're going to need things about f prime, and f double prime, and this might be a mess, but that's okay. Let's rock and roll. So I'm going to dive in with f of x first. They want us to identify the zeros, which means we need to set 0. I've done f of x in green the whole time. Why change now? 0 equal to our equation, right? Zeros are the x-intercepts. And you could keep it as x cubed over 3. You might want it as 1/3 x cubed. I don't know. Maybe that's personal preference. This is set equal to 0, so I'm pretty confident that I'm going to need to factor something out here. I'm going to try to do most of this without a calculator. We might need a calculator though just to substitute in some values. I don't know. Let's find out. So I'm going to go through and say I don't like the 1/3. I'm going to multiply everything by 3 first. So that's going to give me 1200x like so. Now we don't have any fractions. That's right. Nice, right? Then I'm going to also factor out an x. So we have x times x squared minus 1200. And then we can set up two equations and solve. However, I would expect that you guys can be pretty comfortable at finding that x is going to be 0 and then plus minus the square root of 1200. Nothing too terrible. Now, eventually we're going to want to graph this, so we might need to know a little bit more about the square root of 1200. So I'm going to quickly break it down, right? We know that that's going to be 12 times 100. We know the square root of 100 is 10. And then 12 is 4 times 3. Square root of 4 is 2. 2 times 7 is 20. 20 square root is 3. So square root of 4 is 2. If this was the square root of 4, that would be 40. So I'm going to say that's a little bit smaller than 40. I don't know how much smaller, but a little bit smaller than 40. Okay, we have our x-intercepts. Go us. Let's see what else we can find about f of x. They asked us to find any asymptotes. There's nothing that's going to break this equation, so there's no vertical asymptotes. You might remember to find horizontal asymptotes, we look at two limits. We look at the limit as x approaches positive infinity of this guy. I'm pretty confident if you substitute an infinity, that's going to be infinitely large, no asymptote on the right. And same thing if we look at negative infinity, right? This is going to give me x cubed over 3 minus 400x. That'll give me negative infinity minus negative infinity, but this guy's more dominant. I'm seeing negative infinity here, which also makes sense. We know cubic functions look something like this, right? Going to positive infinity and negative infinity. So no real surprises at this point so far. Okay, so I think we're pretty much done with f of x. Let's move into the world of f prime. To tackle f prime of x, we'll need a derivative. As mentioned, we're going to write this as 1/3 x cubed minus 400x, just so we don't have to worry about a product rule, quotient rule, I guess, situation. And so we'll state f prime of x. 3 comes down, cancels the 1/3. I'm looking at x squared minus 400. Not bad. They asked us to find critical points. There's nothing that will break this equation. F prime is defined everywhere, but we can at least find the zeros. Right? 400 equals x squared, which gives us the square root of 400, so plus minus 20. Okay. They also asked us to find the absolute extrema. That's kind of more of an f of x thing, but I'm still going to do it. Right? We know absolute extrema occur at the endpoints or at the critical points. There are no endpoints here. They didn't give us an interval, so I think my absolute extrema could either be infinities, which they almost certainly are, or we should probably evaluate the 20s into our equation as well. So let's go ahead and find f of 20. And yeah, this one I think is going to get a little gnarly with the math, but that's okay. We are going to have 20 cubed over 3 minus 400 times 20. 20 times 20 is 400, times another is going to give us, I think, 8,000. Looks like 8,000 thirds minus, and then 20 times 40 is 8,000, right? Looking pretty good so far. And then we need some common denominators here. So I'm just going to be efficient or lazy, multiply by 3. And that's going to give us negative 16,000 thirds, which is not super helpful. You might want to use a calculator at this point, but I'll just do some quick math. 3 goes into 16 5 times with 1 left over, right? 3 goes into 10 3 times, and then we're just going to get 3's all the way down. So there we go. So, I don't know, negative 5,000, something like that. Okay, and that was f of 20. Let's go ahead and look at f of negative 20 as well. So we get negative 20 cubed. This problem, more than anything, makes you very thankful for a graphing calculator, but that's okay. And so this is going to give me negative 8,000 over 3 plus 8,000, or plus 24,000. That is conveniently 16,000 thirds, which is going to, again, be 5, 3, 3, 3, with 3 repeating. All right, we're doing A-OK here. What are we still missing? Oh, we're missing f double prime of x. Of course we are. F double prime of x, let's take the derivative of this guy. That is just a convenient 2x. Okay, let's set this equal to 0. Gives me x equals 0. Now, we can't call this an inflection point. That's a potential inflection point because we haven't seen if f double prime changes sign around that value. But I think I am probably ready to make our sweet triple sign chart here. I don't have a ton of room, but I think I can probably make it work right around here. And we'll just split this into thirds. Then I'll zoom in to make sure it's viewable. Right? We're going to have qualities of f. We're going to have qualities of f prime. And, of course, our f double prime. So as we go through and look at this, we are going to put in 0 right in the middle, right? And we saw that 0, probably do it like this, caused f double prime to become 0. We also saw up above that 0 caused f to become 0, right? That's what zeros do. what else did we find? Well, we found 20 and also the square root of 1200, which is somewhere around 40. So I'm going to go ahead and put my 20s on here, and then my, what do we reduce that to? 20 squared to 3 on here? Definitely bigger than 20. And negative 20 squared to 3, need a negative. Okay, so we found that the 20s were where f prime came in. That one was much easier to work with. That became 0. And then we found that the 20 root 3s are where my f prime also became 0. All right. Well, we know that our graph is going to, well, I guess we don't know anything yet. Let's work with f double prime first and see what happens. So for f double prime, I need to try a value smaller than 0 into f double prime. Let's try negative 10. 2 times negative 10 is negative 20. And if I try positive 10, we get a positive. So we know my graph needs to be concave down, should switch to green, concave down, and then concave up for f of x. What about f prime? Well, f prime up here, we have x squared minus 400. We are just going to go ahead and substitute in a few values. I think 0 would be pretty easy. Substitute in 0, we get a negative. And then I'll substitute in a really large value, like a million. If I substitute a million in here, that's certainly positive. And if I substitute in negative a million, squaring it makes it positive, so that is certainly positive as well. It tells us that our graph of f will increase, then decrease, then increase. Okay, and then I have 4 possible sections over here for what's going to happen. And so you can really decide on what you want to do here. I think it's probably not needed. Oh, we know something about this already. If we wanted to see the signs of f, notice we already substituted in 20 and negative 20. We found 20 was negative, and 20 was negative, and negative 20 was positive. That's good. So we know that we go below the x-axis and above the x-axis. Okay? And I am pretty confident that since we know at negative infinity we are negative, that this last part will be below. And at positive infinity we're positive, so we're going to be above. Awesome. I think we are ready to sketch this graph. So let's get to it. When we sketch this graph, we're going to go through and we'll do our x and our y-axis. I guess I said that backwards as I drew it, but that's okay. All right, let's get our important x's on here. We have 0, we have 10, 20, 30, 40. I think that looks good to me. We need 20, and then somewhere in here is 20 root 3. I have an inkling that it's larger than 30 and smaller than 40, but we'll go with that. And then we'll go backwards. 10, 20, 30, 40. Same thing. We need negative 20, and then we need negative 20 root 3. And I think those are all our important x values. 0, I guess. Okay. And then we actually have some y values too, which is pretty nifty. Right now, our y-axis actually has to go up very far, doesn't it? These are in the 5,000s when I substituted these in. So I think we should probably go up by thousands, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So here's negative 6,000. Here's positive 6,000. Okay, and let's put some points on there. So we already know a few things. We know zeros. We found these. Our 20 root 3 was a 0. Good. 0 was a 0. And then we also went through and we found those values of f of 20 and f of negative 20 to find our absolute extrema. That's like the candidates test. So negative 20 was at positive 5,000 something. Don't have to be perfect. And positive 20 was at negative 5,000 something. Don't have to be perfect. We also know that at some point our graph goes to negative infinity and a positive infinity. And then we can fill in the rest. Okay, so we see that until we hit 20, we are increasing. And so I'm going to do this twice. I'm going to erase, but we know we increase to 20, we decrease to negative 20, and then we increase afterwards. But that has no concavity or curviness. It says we should be concave down until 0. So I think this first part needs to be concave, do better than that, concave down until 0. And then we have to change our concavity. So now I'm concave up until infinity. There we go, something like this. And I think we have a pretty darn good sketch of a cubic function. Now, again, realistically, you would have a graphing calculator, right? So if the AP exam would never ask you to graph f of x because it's trivial to do with a calculator. But it is nice to see kind of how everything fits together. And I'm going to quickly check my work too. So I'm going to go ahead and graph this on Desmos, but maybe remember how we scaled everything because I'm going to have Desmos do it as well. You should be able to follow along on your graphing calculator and make these really exact same changes, right? So here's my graph. And if you look at it, you might think, well, that's a vertical line. Well, we drew a vertical line as well, right? Just the vertical line, if you zoom in far enough, is just very, 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 very slightly curving one way or the other. So I think what we need to do is we need to scale our axes. So on your graphing calculator, you go to the Windows settings, and Desmos, we'll just go over here, right? And we set our x-axis. I think we went from like -40 to 40, didn't we? That's not what I meant to press. Yeah, this guy and then this one over here. Yeah, we went from -40 over to 40. And we scaled it by tens, I think, yeah? And then our y-axis, we went from -6,000 to 6,000. Oh, it's already started to take shape. Can you see it? And we scaled it by thousands. Look at that. That, to me, looks pretty darn good, especially if I hide this guy. I'll zoom it out just a bit. Look at that. We did really well. What was my actual value here? -34.641. That's our 20 square root of 3. So it was between 30 and 40. That was pretty good, I thought. So yeah, you can tell that by finding all these important points, it tells us how we can scale everything, allows us to see a pretty darn good graph. So thank you for hanging out with me for today. Hopefully it wasn't too terrible, though this last problem is a bit of a bear without a calculator. With a calculator, it's not bad at all. We discussed how f prime and f double prime affect f. And of course, we also looked at some nice triple sign charts. Have a wonderful day, and I'm excited to have you back for next class.